I wanted to review some quadratics strategies. So I gave everybody this flow chart for working through how to identify issues with possible factoring. So let's use this and work through these example questions of some different reasons or strategies for factoring. So this one right here, both of these terms have 3x in them. So you can say because this quadratic has a GCF, it's called the greatest common factor, we factor it out. So 3x times what is x squared? I'm sorry, 3x times what is 3x squared? X. 3x times what is 6x? 2. And since this is just a linear term here, we're gone as far as we could possibly go. Here we have a quadratic with 3 terms, right? So no GCF, 3 terms, perfect square. Nope, because if it were a perfect square, we would have to have 2 terms that were the same here and here, and that's not going to work in this scenario. No, the AC method. Okay, so AC, we take A times C, so 8 times 1, and that's going to give us a number that will give us all possible combinations of numbers that could possibly add together to give us 6 here. So some possibilities are 1 and 8 would multiply together to make 8, but that doesn't make 6 when I add it. And then 2 and 4. If either of those options don't work, then it's non-factorable. So I'm going to put 2x and 4x, and these two are interchangeable. 2 could go here and 4 here, or 4 here and 2 here. Doesn't make a difference. So then I'm going to factor using my box. Greatest common factor this way is 4x. Doesn't matter which piece I start with, so long as I work from that piece once I get done. So 4x times what is 8x squared, so 2x, positive 1, and then that has to be positive 1. And then factored form is going to be putting them in terms of the sides. And then these right here are these 2 components, here and here. So this is just breaking that 6 up into 2 parts. Because it's quadratic, no GCF, not a perfect square. Then we AC method. If it doesn't work, it's not factorable. Okay. Here we have a quadratic, and it's not equal to 0. So we make it equal 0. And we're going to do that by adding this term over to the other side, because I can't factor unless it equals 0. So is it a perfect square? I don't think so. So 4 times 1 makes 4. And then could be 1 times 4, but that's not going to add up to make 4. 2 times 2, well, maybe it is a perfect square. We'll look and see. So 4x squared and 1 and 2x and 2x. All right, it is a perfect square. So 2x, 2x, 1, and 1. So 2x plus 1 by 2x plus 1, or you might write it as a square. If they ask for factored form, though, you might want to leave it there. This one right here, let's go back to our flow chart. It has 2 terms, so that's going to make things a little bit different. So I'm missing my center term, so whenever that happens, something weird is going on. So difference of squares. Well, how would I know? Is this number minus this number, can it be broken up into those squared? So 9, can I break that up into a square root? Sure. 3 and 3. And then x times x is going to give me 9x. And then I'm adding and I'm subtracting. So the square root there is going to be 4. The other half would be minus 4. If you wanted to, you could do this one in the box also, but if it's a difference of perfect squares, as in the b term being gone, the center term being gone, this is the way you want to do it. So because ax squared plus bx plus c equals 0, and bx does not exist, look to the difference of perfect squares. And this last one's sort of a tricky example. First thing I'm going to do is go back to my flow chart and say, does it have a GCF? Yep, A goes into every single one of these. So I need to factor it out, but don't forget it exists. Okay. And then we're going to, after we finish that, go back into the flow chart. I guess I should have put that in there. So A, 3x squared plus 7x plus 2. Okay, it's a quadratic with an A and a C and a B. So let's see if I can factor it using the AC method. So because GCF, we're going to factor that out. Then I need to use AC method because it's not a perfect square. So A times C gives me 6. 3 times 2 equals 6. And we need two numbers that multiply together to make 6, but add to make 7. So my options are 3 and 2, but they're also 1 and 6. Since this is positive, these would make 5, and these would make 7, so it's going to be this as our option. I'm going to use my visual model. 3x squared, 2, and then 1x and 6x. And then I'm looking for my greatest common factor either here or here to start. So I'm going to come out this way. 3x, 1x, 2. That means this has to be a 1. And then just write the sides of the box. Now you might be tempted to leave it like this, but let's not forget that there are a number of those boxes occurring, so we want to make sure we have that up there. Again, if it didn't work out that these two added up to make one of these, then you can say that they're not factorable. And that is your flowchart.